Okay, let's dive into this. It's a story of some seriously global ambition. We're talking about a project to build, get this, a computer the size of a planet.
So just imagine for a second, a single, intelligent network that's designed to operate the world's most critical infrastructure. And here's the kicker. It's completely independent of failing grids and those fragile supply chains we hear so much about. That, right there, is the core idea behind Operation Octagon.
I know, it sounds like something straight out of science fiction, right? But a company called DeReticular is actually trying to build it. And their whole plan, it all starts with Project Octagon.
All right, so first, let's pull way back and take the 30,000-foot view. What does it even mean to build a planetary computer?
Well, it's not one giant machine. It's actually a network of 8 specialized hubs, or nodes, that are spread all across the globe. So for instance, you've got the brain in Canada that manages all the software updates, and then there's the crown jewel in Uganda, which is the main industrial engine. The key thing is they all work together as one single distributed system.
Now, the big idea driving this whole thing is something they call the sovereign stack. And the goal here is to build pieces of infrastructure that can operate in what they call island mode, meaning they can be completely self-sufficient and cut off from external grids if they absolutely have to be.
The sovereign stack itself is built on 3 main pillars. First up, you have the muscle, which is all about generating its own power from things like waste. Then there's the motion. That handles logistics with autonomous vehicles, robots, the whole shebang. And finally, you have the mind, which is an AI operating system called RIOS that, well, runs the entire network.
Okay, so now let's zoom in. We're going to go from that big global view down to a single, really critical node called the blast furnace. And it's located right in the middle of the Arizona desert.
So this is Node 3, and its nickname is the blast furnace. Its entire job is to be a permanent digital twin, basically a real-time working replica for that main industrial site over in Uganda. What this really means is, whatever happens in the Arizona desert gives them the data to predict exactly what's going to happen in the African tropics.
Yeah, its whole purpose is literally to break things. The mission has a great name, Desert Hardening. They take all the hardware, the batteries, the sensors, and just subject them to these brutal 115-degree-plus desert conditions. The idea is to force things to fail in Arizona first, so they can be sure those same parts won't fail out in the real world.
But you know, this is where the story takes a really fascinating turn. We're zooming in again, this time from all that high-tech R&D to a very, very human-scale problem in a small town in Arizona.
71.2. Let that sink in for a second. That is the staggering median age of the people who live year-round in Quartzsite, Arizona, the exact same town where Node 3 operates its field lab.
And as you can imagine, this elderly community faces a critical healthcare gap. The nearest major hospital, it's over 30 miles away. The local transport service, it only runs 1 day a week. So for a lot of people, just getting to essential medical appointments is a constant, difficult struggle.
So this is the really cool part. This is where Project Octagon's technology provides this really elegant solution, and it's one that also just so happens to be a surprisingly profitable business.
So what they did was they deployed a fleet of autonomous vehicles to provide what's called non-emergency medical transportation, or NEMT, basically just getting people to their routine doctor's appointments. By completely eliminating the driver, which is the single biggest cost of operations, they just fundamentally changed the entire economic model of rural transport.
So let's put this in perspective. A traditional human-driven transport service in a rural area like this, it might operate at, say, a 50% profit margin. And by the way, for a transport business, that's already really good.
Okay, but now look at the impact of autonomy. The RIOS autonomous system, powered by a local solar microgrid, operates at an incredible 81% profit margin. It just proves that this isn't only a social good, it is a fantastic business.
This NMET service, it becomes the financial backbone of the whole operation, but they also capture revenue from a huge seasonal surge of tourists. And on top of that, they've created this entirely new revenue stream they call data arbitrage.
So what in the world is data arbitrage? Well, they literally transform the liability of the Arizona heat into a priceless asset. They sell the performance data, exactly how batteries and computer chips break down under extreme stress, to huge companies like NVIDIA and Tesla for their own product development. Pretty clever, right?
Okay,
Let's zoom back out one last time and see how solving one small town's problems ends up powering this massive planetary-scale vision.
This one sentence, it just perfectly captures their whole strategy. All the real-world experience, the hard data, the profits, and all the lessons they learned in Arizona, it all directly enables and de-risks that huge industrial project happening thousands of miles away in Uganda.
Now, the key piece of tech here is called Federated Learning. What it means is that the local AI in Arizona can learn how to manage extreme heat, and then it sends only those learnings, not the raw, sensitive data, to update the master AI. This lets the system in Uganda get all the benefits of Arizona's experience, all while keeping the local data totally secure.
So, by starting with a real, tangible human need in this tiny desert town, Project Octagon gets to prove its technology, it funds its own growth, and it takes one more very real, concrete step toward its ultimate and, let's face it, pretty audacious goal.
And that really leaves us with a final, provocative thought about the future we're all building. If you can turn a desert's brutal heat into a globally valuable asset, what other things that we see as liabilities today could actually be transformed into the core infrastructure of tomorrow?